Problem 18. What is the probability of rolling at least one odd number or rolling a sum of 10 using two number cubes, each numbered 1 through 6? So what you do for number 18 is start this chart that I have here, numbering the top 1 through 6, numbering the side 1 through 6. The top stands for the first die and the side stands for the second die. And what we're going to do is we're going to add numbers together. This is going to be a summation chart. 1 plus 1 is 2. When I roll a 1 and another 1, I get the sum of 2. If I roll a 1 and a 2, I get the sum of 3. If I roll a 1 and a 3, I get the sum of 4, continuing with the pattern. If the second one is a 2 and the first one is a 1, that's a sum of 3 and 4, 5, 6, 7, 8. If the first die is a 3 and the second die is a 1, then that would be the sum of 4. The first die is a 3 and the second die is a 2, that would be the sum of 5. 3 and 3 is 6, 7, 8, and 9. 4 plus 1 is 5, 6, 7, 8, 9, and 10. 5 plus 1 is 6, 5 and 2 is 7, 5 and 3 is 8, 9, 10, 11. There's 7, 8, 9, 10, 11, and 12. There are 36 outcomes here. 6 times 6 is 36. Now that we have our grid, we can figure out the question. The question is asking, first of all, what is the probability of rolling at least one odd number? So our odd numbers are 1, 3, 5. So here we have, if the number is odd, we would get one of the numbers that are in this column, or one of the numbers that are in this column, one of the numbers in this column. We also have to take into consideration the second die. If the second die is a number 1, then that's also an odd number. So I would consider all of the numbers in the first row one that had an odd number. Same thing with the 3 and the 5. Now I count how many of the 36 are colored in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So 27 out of the 36 are produced when one of the die is an odd number. The second part of the question asks, sum of 10. So now I have to look at when the 2 die roll to get a sum of 10. How often does that happen? That happens 1, 2, 3 times. So 3 out of the 36 times, the sum is 10. These are mutually inclusive events. It is mutually inclusive events because they have one number that's double shaded. Specifically, this number right here. This 10 was counted twice. It was counted first when we counted the odd numbers, and second when we counted the sum of 10s. So the way to find out the answer to this probability is take the 27 over 36, add it to the 3 over 36, and then from that we subtract 1 over 36 to represent the one that was double counted. 27 plus 3 is 30 over 36 minus 1 over 36, which is then 29 over 36. And that would be the probability for number 18. Number 19. Number 19 says, identify the constant of variation if y is equal to 8 and x is equal to 2. Given that y varies directly with x. Then write the equation of the variation. So here we start with number 19. We're given that it is a direct variation. So if it is a direct variation, then we're going to start with y equals k times x. It's telling us that y is equal to 8 and x is equal to 2 and is asking us to find k, which is called the constant of variation. Realizing that x is multiplying times k, that k is multiplying times that 2. So to get k by itself, I divide both sides by 2. To get k is then equal to 4. That's our constant of variation. I take that 4 and substitute it back into our first equation that we started. And this would be the equation that they were looking for, the equation of variation. Number 20. Number 20 asks us to solve the system of equations below. And it didn't give us a method to use. The first equation is y equals negative 3/4 x minus 3. And the second equation, 3x plus 4y is equal to 12. Since my first equation is isolating y, I'm going to take what y is equal to and substitute it into the second equation. Doing so, I have 3x plus 4 times what y is equal to, and that's equal to 12. I now take this expression from the first equation and substitute it into where y is in the second equation, and then distribute. I have 3x, 4 times negative 3 over 4. I put the 4 over 1 and the 4 cancels the 4 there to get negative 3x. And then I also have to multiply this 4 times the negative 3 to get negative 12. And that equals negative 12. What I have is 3x minus 3x, and those cancel. And I have negative 12 equals 12. This statement is not a true statement. If that is not a true statement, then the answer would be that these things have no solutions. No solution. They are parallel lines. Which means they never ever cross. They never come in contact with each other. So there is no solution.